Maintenance Publishers. Aviation Maintenance Publishers is dedicated to professionalism in the education and training of aviation maintenance technicians.
The aviation industry is heavily dependent upon sophisticated electrical and electronic equipment for operations, navigation, communications, and a host of other aviation-oriented disciplines. As an aviation maintenance technician, you must be familiar with the fundamentals of electricity and be able to apply your knowledge to the maintenance of the aircraft entrusted to you. The study of electricity must include a definition of terms. It's essential that you understand the terminology and symbols that are used to represent the units of electrical measurement. Electricity may be measured as to quantity, just as a gallon of milk. The basic unit used to measure electrical quantity is the coulomb. The coulomb is represented by the symbol Q. For electricity to be of any practical use, electrons must flow through a conductor. The unit used to measure the rate of electron flow is called the ampere, sometimes shortened to amp. When 1 coulomb of electrons flows past a given point in 1 second, 1 ampere of current is flowing. The symbol for current is the letter I. For current to flow, there must be an electrical pressure, just as there must be pressure for a fluid to flow. Electrical pressure is the result of difference in electrical potential between 2 points, such as the terminals of this battery. The pressure that causes electrons to move is most often referred to as the volt. It will also be written as EMF, electromotive force, voltage, voltage drop, potential, potential difference, and IR drop. The symbol used to represent voltage is the letter E. As current flows, there is always some opposition to that flow. Opposition to current flow is called resistance. Resistance may be thought of as electrical friction and is measured in ohms. 1 ohm is the resistance through which 1 volt can force 1 ampere of current to flow. The resistance in a conductor depends upon the material from which it's made, its length, its cross-sectional area, and its temperature. In general, resistance increases with an increase in temperature or an increase in length, and decreases with an increase in cross-sectional area. The symbol for resistance is the letter R. The Greek letter omega is also used. Electricity is of little value unless it performs some sort of work. The rate at which work is performed is called power. The standard unit of the measurement of power is the horsepower. 1 horsepower is the equivalent of raising 550 pounds to a height of 1 foot in 1 second. 550 foot-pounds of work is performed. Mechanical power units may be converted into electrical power units called watts. 1 horsepower is the equivalent of 746 watts. 1 watt of electrical power is expended when 1 volt causes 1 ampere of current to flow through a conductor. The symbol for electrical power is the letter W. Occasionally, you'll be required to make calculations using very large or very small numbers. These numbers may be made less cumbersome by using scientific notation, or the powers of 10. Some units of electrical measurement are measured in numbers that are too large or too small to be practical. They are represented by metric prefixes and symbols. Notice the prefix pico, or 1/1,000th, at the bottom of the chart. A picofarad is sometimes used to measure an electrical value called capacitance. A picofarad may be represented by the letters PF. A little further up the chart, you'll notice the symbol for micro, or 1/1,000th. It's the Greek letter mu. Some capacitors are rated in microfarads, and you'll sometimes see the picofarad referred to as the microfarad, represented by the symbol μF. Some measurements of electrical current are so small they are given in milliamps, thousandths of an ampere. The symbol for milli is the small letter M. Further up the chart, you'll find a term with which most people are at least casually acquainted. If you look at the meter that the power company uses to measure your consumption of electrical energy, you'll notice that it's rated in kilowatt hours. The term kilo means 1,000. A kilowatt is 1,000 watts. Hydroelectric dams deliver their vast amounts of electrical power in megawatts. Mega means 1,000,000. 1 megawatt, therefore, is 1,000,000 watts. As you have seen, there is a definite relationship between the flow of electrical current, electrical pressure, and the resistance to current flow. That relationship was expressed by the German scientist George Simon Ohm. Ohm's law states that the current flowing in an electrical circuit is directly proportional to the voltage that causes it and inversely proportional to the resistance in the circuit. That simply means that as voltage increases, current increases if resistance remains constant, and that current decreases as resistance increases if voltage remains constant. Ohm's law may be illustrated by the use of a segmented circle. To use the segmented circle, place your thumb over the unknown quantity and perform the mathematical calculation indicated by the remainder of the circle. Voltage on the top half of the circle is equal to the product of current multiplied by resistance on the bottom half of the circle. To find the value of current, divide the voltage by the resistance. To find the value of resistance, divide the voltage by the current. A similar relationship may be shown between power current, and voltage. Again, using the segmented circle, to find the value of power, multiply the voltage by the current. To find the value of voltage, divide the power by the current. And to find the value of current, divide the power by the voltage. How much current would be required to raise this 1,000-pound weight 6 feet in 30 seconds using a 24-volt hoist? There are actually two parts to this problem. First, we must find the amount of mechanical power required to lift the weight. Then convert that mechanical power to electrical power. We know that 1,000 pounds raised through 6 feet is equal to 6,000 foot-pounds of work. 6,000 foot-pounds in 30 seconds is equal to 200 foot-pounds per second. If 1 horsepower is equal to 550 foot-pounds per second, then 200 foot-pounds per second is a little less than 4/10 of a horsepower. If 1 horsepower is equal to 746 watts, 0.364 horsepower is equal to 271.5 watts. Find the appropriate formula to find the value of current when power and voltage are known. Current is equal to the power divided by the voltage. 271.5 watts divided by 24 volts is equal to 11.31 amps. Memorization of the formulas may be helpful, and of course, extra study and practice are encouraged. The important point to remember is that the relationships described by Ohm's law are basic to the study of electricity. Most textbooks include a number of practice problems in electricity. Work the problems and have an instructor check your work. The more familiar you become with these basic calculations, the more proficient you'll become. With increased proficiency, go the ease and confidence that will help you solve more complex problems. Your reward will be a thorough understanding of the fundamentals of electricity, laying the groundwork for more advanced study in this fascinating and vital part of the aviation maintenance field.